Okay, so thank you so much, Nelson, for introduction, and hello everyone who is joining this live stream and this session. So good morning, good afternoon, depending on what time zone you are, of course. And my name is Chintan Desai. I'm working as a software engineering specialist with NICE in Pune, India. My focus is designing and developing systems with distributed components across both bare metal and cloud infrastructures. And as I said, I'm currently working with NICE Systems Limited. Earlier in my career, before NICE, I served as a professional services consulting engineer with Neo4j for quite some time. And that's where I discovered the transformative potential of Neo4j graph database. And this experience inspired me to become a member of the Neo4j community. And I then after started sharing some insights on and around graph database and application engineering with graph database whenever I get some time. So that's something about myself. So in today's session, what we are going to cover. So this session is from the application engineering track. So you guys probably, whoever is joining from the audience, we work on modern applications. So modern applications require scalable, efficient solutions and streamlined deployments to meet the competitive go-to-market. Often we are deploying products which involve multiple components, distributed components, and polyglot persistent strategies. So we use more than one technical frameworks, technological frameworks, and database solutions to achieve our goal. And we deploy our workloads. So we deploy our applications and databases on multiple availability zones, multiple regions to achieve sharding or probably high availability. So the DevOps part for these workloads becomes very critical, and it is an important part of the life cycle. So when I started my journey initially with Neo4j, I had to spend good enough time to understand where and how exactly the graph database stands into or fits into the distributed ecosystem, especially when it comes to the continuous deployment and delivery. Hence, I thought it would be great to share some insights for the people who are starting their application development journey with distributed ecosystem, especially involving graph database, and also for the people who already built a system and planning to evolve the ops side of their things. So what we are going to cover today is we'll understand the Neo4j application fitment. We'll look at both Neo4j self-managed type as well as the Neo4j graph database as a service, the managed service offering from Neo4j, that's Neo4j Aura. And we'll see how the deployment happens with Kubernetes ecosystem, and then we'll understand what is Helm chart and how does it help us to streamline our deployments. And then at the end, we'll talk about integrating Helm charts for the Kubernetes workload deployments and how we can enable a faster go-to-market with this kind of a practice. So that's what particularly we are going to cover today. So initially, first let's talk about the Neo4j deployment type. So as I said, Neo4j is available with both self-managed. Let me change my mouse pointer to a laser pointer. So Neo4j is available as a self-managed and a managed graph database as a service, two types of deployment options, right? So Neo4j self-managed and Aura, or I can say graph database as a service, both have their own advantages. So for the self-managed one, the benefits are it is ideal for the teams who need the complete control over their environment, customization, or a certain compliance with data sovereignty. For example, if someone is building a fraud detection or fraud detection system on a financial data that involves sensitive data, or working on a legacy system data, or they have a strict regulatory requirement, in that case, they can go for a self-managed Neo4j deployment where they can deploy Neo4j on their own premise on a controlled data center kind of an environment. What are the things that involves, whatever are the things that involve the deployment and management of the Neo4j that has to be taken care of by the team who is managing the Neo4j. So it requires some management and administration efforts from the team time to time. And in order to deploy your own self-managed Neo4j, the initial setup may be costlier, but at later point of time, it gives you more control of the whole Neo4j deployment. So that's an advantage of having self-managed Neo4j. Whereas if you talk about the Neo4j DB as a service or Aura, so Aura is fully managed and the cloud native solution that is basically managed by the Neo4j team, and the infrastructure and the management part of the Aura is taken care of by the Aura team. If someone is building a use case like a e-commerce real-time recommendation system or something on a cloud data, Neo4j Aura can be a best fit. Neo4j Aura offers seamless scalability with automatic updates, security, and high availability. So that these are the benefits of using Neo4j Aura. And about the cost, so when you go for Neo4j Aura, basically initially it can be a bit costly, but subscription based model can give you advantage on operational expense over the capital expenditure that you make when you use the Neo4j self-managed. So this is about the Neo4j deployment types. Now let's talk about the deployment of Neo4j when it comes to Kubernetes. So if some of you guys are new to Kubernetes, a brief on Kubernetes and Docker. So Docker is a tiny container that runs your application in an isolated environment or an isolated machine. And Kubernetes is basically a container orchestration platform that helps us to orchestrate and manage your containerized application. So this is a sample container diagram that I have shown that shows the deployment of your application workloads as well as Neo4j self-managed instances on a Kubernetes cluster. So you can see the applications which I have shown in red and applications which I have shown in yellow. So the red one is a transaction processing application. This is just a sample application just for you to understand how the deployment of workload works on Kubernetes. So these are application pods and this is a config map. And this is another application in yellow. So it has two pods, a config map. Both of them has its own cluster IP. And then for Neo4j, you deploy an autonomous cluster with 3 cores. So Neo4j core 1, 2, and 3. All of them have their own config maps and the stateful sets. And it's they follow a cluster IP service, and there is an ingress gateway, which is an entry point to your Kubernetes cluster. And there are disks which are configured for the Neo4j cores that you deploy to the Kubernetes. So this is how the self-managed version of Neo4j and the deployment of self-managed Neo4j with your application, how it looks on Kubernetes cluster. Now going to the app workloads on Kubernetes and Neo4j Aura. So when you use Neo4j Aura, you don't have to go into the hassle of deploying and managing Neo4j Aura on your Kubernetes cluster. So basically, you just take care of your application deployments. So application 1, which is a transaction processing application, and application 2, that's a analytical processing application. So you can say some kind of a reporting application. So application workloads are deployed on your Kubernetes cluster, and then Neo4j is taken care of by the Aura team. But your application needs to connect to the Neo4j Aura based on the environmental configuration or the regional configuration. So that's where the config map of your application plays an important role. So config map is basically, let's say you have deployed this application in a US OS 2 or an Australia region, and then Neo4j Aura is specific to that region. Then your application needs to know which Neo4j Aura instance it needs to connect to. So that's where the config map plays an important role. So that is what's needed to be taken care of when you go for a Neo4j Aura. No hassle for the Neo4j deployment. Now, you can see that there are multiple Kubernetes resource definitions which are involved in both these deployments with Neo4j self-managed and your applications, and in case of Neo4j Aura, but your application has a lot of Kubernetes resource definitions like the deployment, the config map, the service configuration, the gateway configuration, and of course the connectivity part. So you can see that there are a lot of Kubernetes resources which needs to be deployed, and managing these resources for multiple environments, multiple regions, and then lower environments and higher environments, and then managing the deployments and versioning can be really difficult. So that's where the Helm comes to picture. So what is Helm? So Helm is a package manager for Kubernetes. What does Helm offer? So with Helm, you can create your Helm chart. So what is Helm chart? I'll explain it later, but Helm enables you to create your charts. Chart is basically a group of Kubernetes resource definitions which are grouped together for with templated configurations, and you can consistently deploy all the Kubernetes resource definitions using Helm. So Helm is, as I said, it's a package manager. So you can compare it to the other package managers like NPM or Maven or NuGet package manager for C# and Microsoft DICE, and pip for Python people. So with Helm, you can create your own charts, or you can say deployment package. And also you can use the deployment package which are provided by third parties or probably companies like Neo4j. So for example, Neo4j has its own Helm chart, which is provided by Neo4j, and on Neo4j website there's a very good documentation on the Helm installment. So Helm gives you templated configuration. As I said, you can create templates for configurations. I'll show you in the further slides. And then it offers consistency, version control, and it makes the management really simple. So now I'll cover on what is exactly Helm and what is the basic structure of Helm. So Helm, as I said, it's a managed deployment package. So when I say package, so you can imagine a package like this. So this is a package that I have created, and it's a local stack. So for example, my application name is local stack, and I have created a deployment package for my application with Helm, which is called a Helm chart. So in the Helm chart, there are three important things. One is the chart.yaml file, second is the values.yaml file, and the third thing is templates. So I'll go through them one by one. So let's go to the chart file once. So chart file is basically the chart configuration and some details about the chart and the version of the chart. That if you are building a package, for example, I am making a workload for my application, and my package contains some Kubernetes definitions and it is version 0.1.0. So this is the version of the chart, and when I introduce new Kubernetes resources or new configurations to my application, I just upgrade my chart version from 1.0 to 1.1 or 1.2. So that is how the versioning and the chart related configurations are maintained on the chart routine. And the second important part is templates folder. So in the templates folder, you can see that it has the service file, it has a deployment file, and it has a configuration file. So what all resources you deploy with Kubernetes, so they can be grouped together into the templates folder. For example, if you deploy all your resources separately on Kubernetes, you need to run the kubectl add update commands for all these resources separately, and you need to upgrade, uninstall, install, rollback all these components individually. But with Helm, you can group them together in the templates folder, and then whenever you install this particular chart, it takes care of installing or upgrading or rolling back all these components together. Then the third important part of the Helm chart is the values file. So as you can see, in the values file, I have some configuration. So it's plain YAML configuration. It follows the YAML structure, and you can define configuration. It can go up till multiple levels of configuration. For example, the namespace configuration I have given, and in the service configuration, I have defined another level which has type port, mode port, etc. And then resources. So how do these values come to picture? How do they take place while deploying the Helm chart? So for example, I have shown two values file here. So here you can see values file. That's a common or generic values file for my application that I am deploying. And this is the dev YAML file. So in the dev YAML file, you can see that it has some configurations which are different. For example, in the common YAML file, it has local stack namespace, whereas in the dev YAML file, the namespace I have given as local stack namespace dev. So that is how you can provide different configurations per environment. Now, how do the configurations take place into the deployment? So you can see the local stack deployment file. So this is a deployment configuration for my local stack application. I have just added a template for my namespace here. So it says values.namespace. And how does this values.namespace come? So it comes from the values file that you have specified for the particular environment. So for example, for dev, when I deploy, it takes the namespace name as localstack.namespace.dev. So this is how your templated configuration can be simplified with dev, along with grouping of your all Kubernetes definitions into a folder. Now, how do we deploy with Helm? So Helm, I showed you the chart folder and how does it look like, how does the values file look like, and how does the template folder look like, and all the resources are combined into it. Helm, it provides versioning. So it provides install, rollback, upgrade, and uninstall commands. So you can see that the install local stack workload, it's a workload name that I have given, and I'm asking it to pick up the values from the values.dev file. So whatever specific development specific configurations I have provided in my dev file, it will pick up from the dev file, and whatever are the common configurations which are not overridden, it will pick it from the base values file. Similarly, I can deploy it for other environments, like for prod, I can ask it to take it from the prod. For example, this is for the Australia prod region. And here I have specified upgrade command. So it has an upgrade command, whereas if you just make some changes to the configuration or your resources and then you run Helm upgrade, it upgrades the resource definition with only those components which are updated, and it also increases the version of your chart with this new version. And the uninstall command uninstalls all your Kubernetes resource definitions in a single command. So now comes to coming to the Neo4j part. So how do you deploy the Neo4j self-managed instances on a Kubernetes cluster? So as I say, showed over here, so Neo4j already gives you a very good documentation of deploying Neo4j with Helm. So first you just need to pull the Helm repo for Neo4j. So as I said, you can either create your own Helm charts, or you can download, or you can get the Helm charts which are created by people for you. So Neo4j has already created the Helm chart for deploying Neo4j cores, Neo4j standalone or Neo4j cluster instances. So you just need to pull the repo. Helm has the pull add repo update command, and it has a search command for whatever versions which are available. And then you just specify the configuration of the Neo4j core. So whenever you are deploying a standalone instance or probably an autonomous cluster, so as many instances you want to create for Neo4j, you just need to specify the configuration, and then you can just hit the Helm install commands like dev server 1 and then Neo4j, and what is the value file. So instance 1 dev Neo4j core 2, so it picks the values from Neo4j instance 2 dev, and for 3 it picks up the values from the instance 3 dev, and then it installs everything which is required for a Neo4j core to run, like everything behind the scene. And then you can just validate the installation with kubectl commands like get services, get pods. So that's how you can see that how many pods of the Neo4j are running. And then you can also check the logs using the Kubernetes command from the Neo4j logs folder. So it gives you validation that are your Neo4j workloads deployed properly or not, right? Now, that was about how do we deploy Neo4j on a Kubernetes environment, and how do we efficiently deploy application workloads along with Neo4j on your Kubernetes cluster. Now coming to integrating this practice with DevOps to enable a faster go-to-market. So as I said, Helm chart gives you commands. So it can easily fit into the DevOps cycle, and it allows you for consistent, repeatable deployments. Integrating Helm with DevOps is really simple. So, for example, you can use your own CI/CD tools like GitHub Actions, or Jenkins, or GitLab CI/CD, or Bamboo. They have an ability to trigger Helm chart commands. So you just need to have the Helm installed on your executor or runner machines, and then it allows you to execute Helm chart commands. And then you can define your CI/CD pipelines on the code commit or branch pushes. so that whenever you push any new change to the chart or the configuration, it automatically executes first some test cases to validate your deployment, and then once the test cases are passed, it executes the Helm commands to deploy your workloads and as well as your Neo4j cores on the Kubernetes using Helm commands. And as we saw earlier, you can use separate value files to isolate the configuration for multiple environments. So it really helps you in defining multiple environment-based deployment processes. Like for lower environments, you trigger your build from dev branch or stage branch, and then for the higher environments, you make it uh, trigger based on the main branch, and you can supply parameters to deploy on specific regions, and you can specify what configuration file it should read while deploying to specific regions or specific environments, right? And you can use the upgrade and rollback command. It really helps you to enable traceability and auditing part. And then Helm also provides testing framework. So Helm has its own testing framework to test and validate your workloads and your resource definitions before you execute the upgrade or rollback command. And also you can use Kubernetes testing framework. So, I mean, it is just a matter of changing the commands from using the Helm specific testing tools or Kubernetes specific testing tools. So these are some practices that you can implement in an agile manner to implement a robust DevOps process. And it definitely enables you to have a faster go-to-market, and it makes your product releases really efficient. So that was pretty much all I wanted to cover today. I was not able to see the audience screen, so I mean, Nelson, probably you can see if there are any questions. We can take the questions. I'll just say thank you so much for the Neo4j team for organizing this event and giving me this opportunity to share this with the community. If you have any questions after this session, you can reach out to me on my LinkedIn. So I'll just show this LinkedIn. I am available on Medium also. I have my page where I keep posting some articles now and then. So if you have any questions, do reach out to me over LinkedIn, or you can just put the questions on chat, and we have, I think, 5 minutes. So Nelson, we can take some questions if there are any.